Hi there, welcome back to this channel, and in this video I'm going to take you through limits of stepwise functions. So in our previous lessons we've dealt with limits, the concept of limits, as well as limits of rational functions and constant functions. So we continue from here, taking the limits of stepwise function. Please, if this is the first time you have been on this channel, kindly subscribe to support and watch this video to the end. So find the limits of f of x as x approaches x naught, where x naught is -7, -4, and 0, and the function f of x is given as e, where x is greater than -4, e plus ln 2, where x is greater than -7 and less than or equal to 4, right? So let's solve this. So you know that for a limit to exist, limit as x approaches x negative should be equal to limit as x approaches what? X positive, x not positive. Okay, so the left hand side should be equal to the right hand side, or you say that no matter the path you choose, you should always have the same limits. That should be the rule for limit to exist. So we can now proceed. So for the first limit, limits of f of x as x approaches, so the first x naught is -7. Okay, so for -7, you realize that when you come to the piecewise functions here, you analyze it. Where does the function has -7 in it? So the -7, as x approaches -7, the part of our function being in play is e plus what? Ln 2. Because the function, when you say stepwise function, it has been broken into pieces. So the -7 domain is only affecting what? This piece of what? The function. Only this piece of the function. Okay. So when x is greater than -7 and less than or equal to 4, we are getting this part of the function. So obviously this is what? A constant function. Remember, as I said, a stepwise function is just a series of what? Constant function applied on different domains. So this is a constant, it's a number. This is also a number, right? So as the rule says, whenever you find the limits of a constant function, no matter where you approach it, it's still the what? The constant. So limits f of x as s approaches -7 is simply equal to e plus what? Ln 2, because it's the only part which is affected by -7. Then now let's see the second part. So limits of f of x as x approaches what? -4. That's the second one, right? -4. So for -4, you ask yourself, where is -4? So sorry, here is -4. Okay, so the function is saying that x is greater than -7 but less than or equal to -4. That one will fall here or fall here. And when x is greater than -4 to fall here. So let's see, meaning that -4 has two what? Sides, one on the right and one on the left. So let's find the one on the left. So -4, left of -4. You realize that when x is less than or equal to -4, this is the left side of f of -4, left side. That one, the function is given as this. So meaning for that one, our answer will be what? E plus what? Ln 2. But limits as f of x as x approaches -4 positive on the right side, that is for this side, positive of what? That one is giving us what? E. And now this and this are not equal, right? So meaning that as x approaches 4 minus is not equal to as x approaches what? 4 positive. Therefore, you can say that the limit does not exist. You can say that the limit does not exist, right? Limit does not exist. So meaning that for a limit to exist, wherever you approach this point, you should get the same answer. But now you are getting this, you are getting that. So meaning the limit will not exist. Then finally, let's find the limit as x approaches or 0, right? As x approaches 0. So as x approaches 0, which range do you think you can get? Now within this range, there is no 0 here. Take note, there is no 0. S greater than -7 to -4. But when s is greater than -4, it takes from -4, -3, -2, -1, 0, and what ahead. So meaning the answer will be what? This one, E. So as x approaches, so limits as x approaches 0 of f of x is simply equal to A. Thank you for being with me in this video. Please subscribe, like, and share if you found this useful.